everybody. Sorry I can't be there in person, but I have this video here that I hope will do the trick for you. Let's go ahead and get started. So some changes for quarter two. We'll talk a little bit more about this when I get here, but we are going to be doing, I do your note check every class. This is also going to be our homework check. I don't want you guys to turn in your homeworks anymore because I want you to keep them. I want you to have them so you can study them for quizzes, study them for tests, all of that good stuff. So when I come around and I check your homework and your notes at the same time. And if this works, we'll keep going. If not, we'll go back to the turn-in system. Also, a new cell phone policy. If you look behind you, all of the little bubbles are gone. I felt like those weren't really very effective in cell phone management. So what we are going to do instead is if you have a problem with your cell phone, he is going to go inside the little CalPAC storage that I have behind the door. So first time CalPAL storage. First time, I'll just ask you to nicely put it away. Second time, if you cannot handle it yourself, I will help you handle it and it will go in there. And we'll talk a little bit more about that as we go, but just those are two new things that I want to have on your radar. So let's get into the lesson. So take a moment and look at this. We're going to talk about 4 special types of triangles today. So one starts with an I, one starts with an E, one starts with an S, and one starts with an R. So take a minute, 30 seconds or so, and see if you can remember what those special types of triangles are. And I'll give you about 30 seconds. Okay, 30 seconds is too long. That was a lot. So we're going to call that 15 seconds and call it good. So if for the first one, if you said the word isosceles, good job. So an isosceles triangle, hold on, I'm ringing. Here, answer it. It's your grandma. Sorry. An isosceles triangle, and go outside, means that 2 sides are the same. So 2 sides are the same. Okay, that could be something that looks like this and like this. So if I was a perfect artist, those would be the same, and then we have one side that's off. If for E, you said equilateral triangle, good job. You can see the word equal in there. It is where all 3 sides are the same. And that would be something like that. Pretend I'm a perfect artist and all 3 of those are the same. S is one that people struggle with. They don't do so great with the S. It's not very common. If you got a good job, it is a scalene. So a scalene triangle means that no sides are the same. So something like this, and like this. Something, I don't know, something like that. Imagine that was perfect. Oh, that actually kind of looks like a isosceles. So let's make that a little wider. And then that one. There we go. That would be better. And then the last one is a right triangle. We know right triangles. We love right triangles. We use them all the time. Right triangles are right triangles because they have that right angle, which is a perfect 90 degrees. All right, so those are the special types of triangles that we've got. All right, so let's talk about some, how do I want to say this? Like markings on a triangle. So if on the inside you see something that looks like that and something, oh, nope, not that. Something that looks like this and something that looks like this. So if you see something like that, it means that the angles are the same. If you have multiple ones, then you just do multiple lines and you match them up. Same with this. If you have something that's like this and like this, that means that your side lengths are the same. Are the same. Now, why is that important to make that distinction? Now, what connection is there between side lengths and angles? So the angle is the opening, and that opening from one end to the other can be covered by a length. If the angle is the same, if 2 angles are the same, their side length will also be the same. Their side lengths are the same. Okay, so give you a second to write that down. Oh, sorry, that was gross. So your angles are the same, your side lengths are the same. Why is that important? Because if this angle makes that length, then this angle makes that length. And it would be exactly the same since they're the same angle. Okay, so let's keep going on. So let's use that principle. Can we figure out what B is? So we have B right there. And if we're looking, I know that 65 degrees makes a side length of 15. Since this is 65 as well, this will also be 15 length. Can we figure out what A is? So let's erase this stuff. Can we figure out what A is? So A is chilling right there. I don't know anything about that angle. I don't have enough info. So not enough info to figure that one out. And then lastly, it wants to know, can we figure out what C is? Now, we haven't talked about this before in our class, but maybe you've seen it before. The inside of an angle of a triangle, all three angles always add up to what number? Okay, if you said 180, good job. So 180 is what all of the angles inside of a triangle will add up to. So if we take our 180 and we minus our 65 from one, and we minus our 65 from another, 65 and 65 is 130, so 180 minus 130 would be 50. And then we can figure out what that angle is. Okay, so let's move on from that. And we're going to talk about, that's a good segue into what is a theorem. Now, a theorem, if you haven't seen it before, you have seen it before because you've seen like Pythagorean theorems, any other theorems that we have, any straight angle theorems, anything like that. And a theorem is a mathematical fact that has been proven true for all numbers. So it works, it works, it works, it works. So anytime you see a theorem, it's kind of like a law or a rule. Okay, the first one that we already talked about, the triangle angle sum. If I have one angle, another angle, and a third angle, all three of those will forever and for always add up to 100 degrees. And this right here is the symbol for angle, and it just means angle 1. So angle 1, this would be angle 2, this would be angle 3. So that's what that little symbol means. Another one is the straight angle theorem. So we know if we have a straight line, that's like two 90-degree angles. And two 90-degree angles would add up to 180 because 90 plus 90. Now, it doesn't matter where I put that line. It doesn't matter if I put it there, if I put it there. I'm slicing up the same 180. And so it doesn't matter where that line is. If you have a straight line, it'll always equal 180. So this is a just watch one. There isn't a spot in your notes. But if we're looking at this, x and z, well, x and z come together to form a straight line. So it would just be 180. It doesn't matter where the slice is. Same with this, x and y and z, even though they are three parts, these three parts come together to form that straight line. And so those would equal 180. Oh, sorry, I need to quit sniffling. That's gross. All right, so our straight angle theorem. This is another just watch one. If I needed to know what z was, I know that both of these come together to equal 180. So if I say 180 and I minus 150, that is going to equal my z, which is 30. Same with this one. I've got x plus 30 plus 70. They all form a straight line. So if I take that 180 that they're supposed to form, and I minus the 70 and I minus my 30, that would leave me 70 and 30 is 100. So 180 minus 100 would just be 80. And so that missing piece would be 80. And I probably better put these on there, degrees. So degree, degree. These are all should be degrees. Okay, pencils back up. Another one that you want to learn about is the vertical angle theorem. So I'm just going to make something up. Let's pick an easy number like 50. So if that side is 50, I've got a straight line right here. I know that this side needs to be 130 so that my straight line is 180. Then I go again, I've got a straight line right here. So I need this side and this side to equal 180. So that would be a 50. And then if I'm looking at this, I have another straight line, and this would be 130. So whenever you have an angle that's across from itself directly, like these two guys are, those angles are going to be the same. And that's what this symbol means right here. It means like the same, but not the same, because this angle and this angle, although they have the same value, they're not the same angle. So it's like a same but different. Same but different. Okay, so there is our vertical angle theorem. So we're going to use those three angle theorems to kind of help us out today. So if I'm looking over here, on your notes, I meant to do this one. So add this. There is angle 2 that I want right there. So don't be pressured to answer them in any order. You can answer them in any order that you want. The fact that they're 1 and 2 is just for labeling. And so I'm actually going to answer angle 2 first. So I'm looking here and I've got a nice straight line. So I know if I do 180 and I minus 37, that is going to give me my angle. So 180 minus 30 is 150. 150 minus 7 would be 143. And that is for angle 2. For angle 1, I can see that I have got a full triangle. I've got 1, 2, 3. Oh, I guess 3 right there. And so I can say 180 degrees minus the 37 that we have, minus the 24 that we have. I'm going to throw that in my calculator really quick. I don't want to do that one by hand. Minus 24, and it equals 119. And that's what goes in spot 1. So we didn't use the vertical angle theorem, but we used the straight angle theorem and the triangle sum theorem. Okay, let's try another one. So I'm going to leave this up for you guys for a real minute this time. I'm going to sit here in silence for 1 minute. I want you to try and solve these. So try and find 1, 2, and 3. So a full minute starts now. Everyone should have pencils moving. You should be trying. If you are struggling on starting, I would try angle 1 and our triangle sum theorem. If you're still struggling for something to do, we've got a lovely straight line right here that can help you solve number 3. And then once you've solved number 3, number 2 will be easy. Okay. So that is our minute right there. Let's figure these out. So on angle 1, I see I've got a full triangle right here. So I can say 180 degrees minus the 66 minus the 84, and that will be my measure for angle 1. And that ends up being 30. So this is for angle 1, so 30 degrees. Angle 2 I'm looking at, and 2 is kind of hard to figure out if I don't have 3. I could use a full triangle theorem, but because I don't have 3, I'm not going to be able to do it. So I'm actually going to skip and do 3. 3 is a straight line. Straight lines are always 180 degrees. And then I'm just looking at this section and this section. Let me kind of erase these. So I am just looking at this section and this section right here. I'm not worried about those two. Those two are not included in my straight line. So when I have these, I would have 180 minus 84, which would be 96. And then that is going to be my measure of angle 3. So 96 degrees. All right, and it's always a good idea, once you have your angles, go ahead and throw them in if you need to, because then that helps you paint a better picture. And that was 30. Now it's going to be pretty easy to find angle number 2. I've got 180 degrees in a triangle, and I'm going to minus my 96 and minus my 43. That leaves me with 41. So again, don't be afraid to follow these out of order. I did 1 first, then 3, then 2. If you did a different order than me or a completely different way, that's fine as long as you got these numbers. We can get pretty creative with these ones. All right, let's keep going. We've seen this once, we've seen this twice, we've seen this 100 times. It is a Pythagorean theorem. This is, if you're interested in seeing a little video, I'm not able to play it right now because this is a PDF, but it is a living proof that shows if you have, oh, maybe I can open it. Ooh, and I oop, aha!
Hi, my name is Alex. I'm 10 years old and I've been learning to play with Simply Piano.
No one's gonna believe a 10-year-old is learning piano all by herself with an app.
In fact, I don't want any of this. We're moving away. Oh my gosh. Okay. All right, so a squared plus b squared equals c squared. So let's use a couple of these. So whenever you have your Pythagorean theorem, your c is always opposite your height or your right angle. So that one is going to be my c. My a and my b are interchangeable. I could have called my a 9 and my b x, but this is just fine. Now we're going to want to use our Pythagorean theorem formula that we have right there and write the whole thing out. So a squared, my a is an x, b squared, my b is a 9, equals c squared, which is the square root of 170. And then don't forget to put a squared on all of those terms. So x squared is just x squared, though that stays the same. 9 squared is 81, and then the square root of 170. Remember, whenever a square and a square root meet, they fight and die, and we just have the 170. From there, it's pretty easy. We just say 170 minus 81. So that gives us x squared equals 89 when I minus that 81 over. And then all I have to do is square root, and then I get that x is the square root of 89. 89 will not square root any further, and so I am more than happy to have us end right there. All right, let's try one more. So Pythagorean theorem. All right, so which one of these needs to be C? Okay, if you said 9, good job, because that's the one across from the Pythagorean theorem or across from your right angle. A and B don't matter. It can be one, it can be the other, it doesn't matter. And so I make sure to write out my whole thing. So that is my a squared plus my b squared equals my c squared. So that is all drawn out for you. Then I do the math. X squared is just x squared. Whenever a square root and a square meet, it is just 30. They fight and die, they're gone. And then 9 squared is 81. And then we're going to do 81 minus 37. That gives me x squared equals 44. And then I square root. Square root of 44 simplifies to 2 square root 11. For this lesson, I'm not too pressed if you want to leave it as square root of 44. But if you remember when we were doing our breaking apart, 44, that's the same as 4 times 11. 4 is the same as 2 and 2. 2 gets to come out. 11 doesn't have a pair and stays in. So there's that if you're looking for the behind the scenes. So you got a couple of Pythagorean theorems waiting for you. All right, now this is probably the meat and potatoes of this lesson, our transversal angle relationships. So I forgot to draw these on here, but I want you to draw 2 little arrows. Does anybody know what that means? Okay. If somebody said that they were parallel, good job. So that means these 2 lines are parallel. They never touch, they never get closer, they never get further, they stay exactly as they are. This line that's going across those is called the transversal. It is traveling across those parallel lines. It's transiting across those. So that is our transversal. Now, when we're talking about the names of these features, interior refers to anything that happens inside of the parallel lines, and then exterior refers to anything that happens outside those lines. So as we're going, realize interior means the outside, exterior means the outside, and transversal will either be on the same side of the transversal or the opposite side of the transversal. So let's look at these angle theorems. Yours are shaped a little different. Yours are vertical just for the saving some space on the paper, but follow along with it this way. Try and write it in the box. So corresponding angles are angles that are in the same place. So for example, if I have a angle right there, that is an angle that is to the right of the transversal and above the parallel line. If I have another angle right there, it is to the right of the transversal and above the parallel line. Those are going to have the same value. So the same value. Another example could be like this one right here. I'll do a square for that one. That one is to the left of the transversal and below a parallel line. So kind of take about 10 seconds and think about where his corresponding angle would be. And if you thought it was right there, good job. Those would be exactly the same. So I'm going to label these. You don't have this, so don't worry about labeling them, but 5, 6, 7, 8. There's tons more corresponding angles. Oh, and let's put that they're in the same place. Now, obviously, they're not in the same place. They're in completely different places, but relative to what is going on in the transversal and in the parallel, they're essentially in the same place. All right, so I'm looking at 4. I want you to kind of think about it for a minute and tell me which one would go along with 4. All right, if you said 8, good job. Let's see, what's one we haven't done? Which is one that would go along with 5? Okay, if you said 1, good job. So it's just depending on where they are in respect to the parallel lines and the transversal. Up, down, left, right, that sort of thing. All right, so let's go on to these next ones. They both start with alternate, and then we have interior angles and exterior angles. So alternate would mean, when we're referring to alternate, we're referring to this. So alternate is kind of like the opposite. That's a good enough explanation for this one. Alternate is like the other side. And so when we're talking about opposite, we're talking about our transversal line. So alternate our transversal line would mean one's on one side, one's on the other, and they're in the interior. So this one and this one right here, they are on the alternate sides, but they are in the interior. This would be one, and this would be one as well. Now, those are always equal to each other on both cases. So they are equal to each other. Now, alternate, they are going to be on the opposite side, and exterior, those are going to be on the outside of our parallel lines. So this one, and kind of think about that. So on the alternate side, on the exterior, would go right there. And then same with this one and this one. They are on the alternate sides and they are on the exterior. Those would be equal to each other. Now, if you're thinking, and this is just a look thing, you don't have to draw this. If you're thinking, well, that's alternate, except those aren't going to be equal. That's a straight line. They're going to add up to 180. So don't get those confused. Okay. All right, and let's go on to our very last ones. Are consecutive. Now, consecutive means one after another, like 2, 3, 4, 5, 6. Those are consecutive numbers. And then the interior and the exterior, that's going to be the same thing that we're talking about. So consecutive, same side. And then interior on the inside. So this guy and this guy, they're on the same side. They're on the interior. These ones add up to 180. Now, this is a really easy lesson because the answer is either add up to 180 or equals for about every single thing there. This one and this one would also be the same, all consecutive interior. So consecutive, same side, exterior on the outside. So that is going to be this one and this one. Those would be the consecutive interior angles, exterior angles. And then this one and this one would be your consecutive exterior angles because they're on the same side. And those also add up to 180. Okay. Now, I do expect you to memorize these. It feels like there's a lot of them, but it's really the same. Corresponding, if it's in the same space, it'll have the same value. If it's an alternate interior, they're going to be equal. and then we can remember that by remembering what alternate and interior means. And then consecutive interior, they add up to 180. So kind of only 2 or 3 things to remember. All right, so let's keep going. Let's look at these. So we need to solve these last 3 that we have right here. Here's a reminder telling us what is interior and what is exterior, and then we have our types up here. So if I'm looking at this, I don't have my rules or anything. I'm looking and I'm saying, okay, they're on the same side, so it's consecutive. So it's going to be either this one or this one. And they're on the interior side, so I know it is not going to be that one. Now, consecutive interior, if we go and look, consecutive interior angles add up to 180. So this guy and this guy are going to add up to 180. So I do one angle plus my other angle, and I add that together, and it would be 180. Now, if I'm looking at this, this number and this number, those are just plain old numbers. I can add those together. So 125 plus 11x equals 180. I can subtract that 180 over. I'm going to skip drawing it, but we're just minusing that 125. And so that is 55. And then the only thing that we have left to do is divide that 11 away. And so we get that x equals 5. And then these are supposed to add up to 180. If I say 11 times 5, if I put a 5 right here, 11 times 5 is 55, plus 5 is 60. 60 plus 1, 20 would be 180, so we know we done did good. Okay. All right, let's go on to our next one. Give you a second for those who are still working on it. All right, so let's go on to our next one. We have signs on opposite sides of our transversal. Remember, this guy is our transversal. This guy is our transversal, and they are on opposite sides, otherwise known as alternate. So we don't have any consecutive situations. It's going to be one of our alternates. And since that is on the interior side, we are going to be looking for our alternate interior. Now, when I go up, my alternate interior angles were equal to each other, and so I'm going to set those mamma jammas equal to each other. So I'm going to write 3x minus 6 equals x plus 94, and then I'm just going to solve. I'm going to move my x to the other direction, so if I minus my x, I will get a 2x, and then I'm going to add 6 to my other side, so that would be 100. So I'm skipping writing the little steps in between. Hopefully we're keeping up and we're following, and that's not too bad. And then all I have to do is divide that 2 away from my x, and I get that x equals 50. And we box that in. Okay. So give you a second to write those down. Okay, and let's move on to our very last one. Okay, so we have multiple variables going on. We've got x's and y's in this one. Now, even though it is true that this one and this one form a straight line, I can't use that because one of them is an x and one of them is a y. So I'm going to concentrate on just solving my x's right now, and I'm going to look at this one and this one. So those guys are on opposite sides of my transversal. Remember, that's my transversal. So I'm not going to use consecutive interior, and I'm not going to use consecutive exterior. I need to use, they are on alternate sides, and they are on the exterior. So I go up and I look at my notes. Alternate exterior angles are equal to each other. So I can just set those two things equal to each other. And write kind of small because we're going to do 2 formulas on this side. So let's write on this side first. So 10x minus 17 is equal to 8x plus 1. I'm going to move my 8x to the other side using subtraction. So 10x minus 8x would be 2x. And then I'm going to add my 17 to the other side. So 1 plus 17 would be 18. And then all I have left to do is divide by 2. And I found that x equals 9. So I can box that in. Now that I know that x equals 9, I can come back and re-examine the fact that this is a straight line. If I put a 9 where that x should be, because I found out that x was 9, 8 times 9 is 72, and then plus 1 means that this angle is actually 73 degrees. Now I have a straight line, and I know that straight lines equal 180. So I'm going to say 6y plus 29 plus 73 will equal 180 degrees. Now these two pieces can go together. 29 plus 73 is 102. So I have 6y plus 102 equals 180. If I minus my 102 over to the other side, I get that 6y equals 78. And then all I need to do is divide that 78 by 6, and I get that y equals 13. Okay, box that in. So we've got both of those. Now, the time is yours. Remember that next time we're not turning in the homework. We're going to just check it off with Miss Pasnelli instead of turning anything in. And then I did kind of want to go over, give me just a second, some of our homeworks that I know we're going to struggle with. So, number 14. I want to start you guys off on number 14. Let's see. Is there a way? I just want one big filled text box. Sorry, I'm just using this program for the first time, and I don't think I can. All right, so here's what we're going to do instead. I'm just going to draw the image over here. So this is number 14 on your homework. If you haven't had a chance to get the homework, pause and go grab the homework really quick, or even leave this up. And it's a big old mess. It looks like this, and one of these. So this is two parallel lines with two transversals. So this is a 2y, this is a z, this is an x, this is a 90, and this is a 2x. Now this one's kind of hard to start because there's so many variables, but we want to start with the fact that this is a straight line. So 2x plus 90 plus x equals 180, and then you can solve for x from there. So 2x and x put together would be 3x, and then if I minus that 90 over to the other side, I would be left with that. So I added the 2x and the x to get 3x, and I minused the 90. 180 minus 90 is 90. And then all I need to do is divide by 3, and I get that x is 30. So there is a tip to help you start number 14. All the rest of them shouldn't be too crazy. And I will be back on Tuesday. The time is yours. Thank you.